If you were in today's mandatory Zoom, you're not going to need this. Do now. We certainly did this much. You're welcome to move ahead to wherever we left off on the notes. But I always do the whole thing just in case someone was absent or had some Zoom issue, which has happened to all of us from time to time. We graphed this line by finding inputs, or I should say selecting inputs, values for x, and then substituting those values into the equation to calculate the outputs, the y values, and by doing so finding ordered pairs and graphing the points, connecting the points to show the line. That, believe it, even though that's pretty easy, you learned last week that that's not that hard to do. It's actually the hard way to do it because there's an easier way. If we get lucky, or if we know how to create this situation where y is isolated on one side of the equation, that's called slope-intercept form. And slope-intercept form is y equals mx plus b. Y is y, the output value. X is what it's always been, the input, the independent variable. But m and b are the slope and the y-intercept for the line. That's why it's called slope-intercept form. So if you were going to graph a line from the equation, you could simply, if it's in slope-intercept form, if y is isolated on one side, you could simply look for b. You begin with b. Begin with b. b for this line equals positive 4 because it's mx plus b and I have negative 2x plus 4. So I'm adding positive 4. And so if we didn't already have this blue line graphed, we would put a point. I should get a different color actually. We would put a point at positive 4 because that is the y-intercept. That's where the line crosses the y-axis. And then in order to get one more point, which is all we really need, because if we have 2 points on the line, we can draw the line through those 2 points. We have to understand that m is the slope. So m is the number that's being multiplied by x. It's called the coefficient of the variable term. So if m is negative 2, we remember that slope is the change in y over the change in x. And so you represent negative 2 as a fraction, it's negative 2 over 1. Now pretend we didn't see the blue line. All we have right now is this red point at y equals 4 because that's the y-intercept. We could then apply the slope by applying these two changes. The change in y is negative 2. That means we move down 2. That's the vertical change, negative 2. The change in x is positive 1. So from there we would move 1 to the right. And if I have the y-intercept and this other point, I could draw the line. Let's try to do it with this equation. Y equals 2/3 x minus 1. The first thing you should always do is you should write the general slope-intercept form, y equals mx plus b. And then you should ask yourself, what is b and what is m? Now, many students, when they first start doing this, they look at this equation, they're going to tell me b is 1. b is not 1 because it says mx plus b. We're not adding 1, we're subtracting 1. But subtracting is the same as adding the opposite. So this is the same as adding negative 1. So all year we've been saying subtracting is the same as adding the opposite. So if you have a linear equation in slope-intercept form and you're subtracting a number from the variable term, just don't forget to think of it as adding the opposite. And if you do that, you'll realize that b is not 1, b is negative 1. So once we know b, we know the y-intercept. You begin with b. If we know the line intersects the y-axis at negative 1, I can plot a point on the y-axis at negative 1. Now I don't know how the line's going to cross through that point. I mean, I don't know the angle, I don't know exactly where any other point is, but I know that it crosses at that point. And all I need is one other point. The 2/3 is going to give me my other point because it's mx plus b, and I have 2/3 x. So m is 2/3. M is the slope, delta y over delta x. So if delta y over delta x is positive 2 over positive 3, I just, from the point I have, from the y-intercept, the only point I know, I apply this vertical change. Delta y is positive 2, so from this point I move up 2. And then delta x is positive 3, so I move up 2, and then I move right 1, 2, 3. And I have the second point on my line. And the line would go like this. Okay, that's how you graph a line from a linear equation in slope-intercept form. And it avoids having to do all that XY table stuff, which is fine. I mean, that's just another way to do it, but it's much easier. You can start to graph line. You'll see how quickly you can graph lines once you get the hang of it and think about what is B, what is M.